Hi everyone, this is Professor Abby again. Just wanted to give an overview of our last chapter, which is chapter 13 on programming and languages. So this is the last chapter. It's just going to be a very quick, I'm hoping to make it a 10-minute review or overview of the chapter 13 titled Programming and Languages. So let's go with the learning objectives real quick. Um, the first learning objective, of course, is to define programming. Just state what programming is, have a better understanding of what programming actually is, and describe what the 6 steps of programming are. So remember in the last chapter with the systems analysis and design, we had the 6-step system life cycle. It can get a little bit confusing because in this chapter as well, programming and languages, we also have what's called a 6-step programming cycle. And some of the elements in both are somewhat similar. I guess that's why they have both chapters next to each other. So, you kind of want to know that there are differences between these two procedures. And there are similarities, but they're not quite the same, okay? All right. Second objective is to compare design tools, which includes top-down design, pseudocode, flowcharts, and logic structures. Again, some similarities, because if you remember in the last chapter, when we looked at the second step of the life cycle, the systems analysis life cycle, which I think was systems analysis, we also had some tools that we used that included something that was similar to flowcharts. So in this chapter, which is the chapter on programming and languages, we have design tools which are used in the programming process. And some of these design tools, for instance, are called a top-down design, pseudocode design, flowcharts, and logic structures. And we'll look at some of these in another minute or so. The third objective is to describe program testing and the tools for finding and removing errors. So if you know anything about programming, if you've ever attempted to program, you'll know that when you do program, you have to test to make sure that the program works. All right? Very often when programmers do programming and produce something like an app, let's say, sometimes it works, sometimes it doesn't. When you find an app that works erratically, it usually boils down to not doing enough testing to make sure that the programming was done correctly. Okay, so program testing, very important. And of course, there are tools for finding and removing errors in programming and coding as well. We'll go through those real quick. Number 4 in learning objectives talks about describing what case tools are and something here called object-oriented software development. Okay, case tools are another set of tools that are used in ensuring that programming happens the right way. Remember in the last chapter where we had an alternative tools if you did not want to use the 6-phase life cycle. Well, same thing with programming. We have what are called case tools. In the event that you do not want to go through this 6-step programming process, you could use an alternative. These are called case tools, pretty much almost like pre-made programming tools that are used to achieve the same objective. So it pretty much depends on what you decide to do, and sometimes it also boils down to cost as well. Okay. And number 5 here, this is a pretty important part, and the part that I expect you guys to review and revise and retain in your memory, is explaining what the 5 generations of programming languages are. This boils down to this, guys. Programming can start from the very base level, okay, to a more higher level of language that's easier for us humans to understand. So your base level really is called machine language programming, and this is the programming language that probably only the computer can understand. All right. So whoever does the coding writes the code. It's just meant for the computer to interpret, not necessarily a human being. Now, as time has gone on over the years, it's become more necessary for human beings to be able to understand programming and coding language. And so we've started to have different levels. You've got the first level, second level. Nowadays, what we're really dealing with is third generation programming languages. So, things like C++, that's a programming language, or Java, or Visual Basic. They would probably be what you might consider third generation programming languages. We also have fourth generation programming languages, which at an even higher level enable us as humans to understand the actual programming language. Let me give you an example that probably would make more sense. Back in the day, maybe 10, 15 years ago, if you were designing a website, you actually had to know HTML coding. You actually had to know how to do it for you to even attempt to build a website. Okay? Nowadays, you do not necessarily have to know HTML. But what's really happening is we have these fourth generation coding languages, which makes it a lot easier for us humans to understand what needs to be done. And the coding language is almost written in regular English. So we're able to work what used to have to be done was you'd have to work on the back end doing the HTML programming. Well, these days you don't have to do that because the programming languages have become so advanced that we can understand and we can apply it. There's also fifth generation programming languages, but that might be a bit too way ahead. We're talking programming fused with artificial intelligence so that computers are able to do the programming without any human input. So that's going quite far, but we're already seeing it happen in artificial intelligence with things like Alexa, Cortana, and even with driverless cars. That's all the fusion of programming and coding being fused to interact with artificial intelligence without any human input. Okay? All right. So let's real quick go through, see if we can do it real quick. Just pick out a few things. One of the important things I want to point out here is the program specification stage. Okay? So that's the first step in this programming six-step program cycle. It's the program specification. And this is where you're actually determining what is the program going to solve. Okay? If there is a problem, okay, what is this program going to solve? Why are you writing the code? What problem is it going to solve? So this is where that is specified and written down clearly so everyone knows what problem the program code is going to solve. Okay? So it talks here about having program objectives. What are the objectives? What are the outputs? Okay? So at the end of the day, once this program is written, what's the expected output? And what input data is going to be required to make this code successful? Okay? Also processing requirements and also a program specification document. In all phases, just like in the system's life cycle phase, what's going to be required is a report or a specification document that has to be produced at the end of the process. That's extremely important. Okay? All right. Let's go on to next step, which is program design. All right? So after program specification, you begin the program design, and this is where you begin or you plan the solution by using what's called a structured programming technique. We're not really going to go into those details. You will have to read some of this. So I'm just giving a general overview. But the program design really is based on what solution do you want out of this program. That is going to influence how the program is designed. There are a couple of tools that are used for this. There's a top-down program design. in order to identify the program's processing steps. Okay, something else here called pseudocode, and this is what I want you guys to read up on, and of course flowcharts as well. Okay. Um, Logic structures. Well, logic structures are really linked to the flowcharts, how the flowcharts are designed. This is what the book says. Well, how do you link the various parts of the flowchart? The best way is a combination of three logic structures called sequential, selection, and repetition. For this part, guys, I'm going to really expect that you guys read through this to get some kind of an understanding of what logic structures mean. It's going to take me a while to go through it on this short video. Third step is the program code. So when you actually write the program, it's called coding. And this is where you use the logic that you have developed in the prior phase, okay, the program design phase. So the third step is called program code, and this is where you actually write the program, and this is the coding process. Okay. There is something here about a programming language, and I just wanted to do a quick definition. It says here that a programming language uses a collection of symbols, words, and phrases that instruct a computer to perform specific operations. So, real quick definition of what a programming language is. A programming language uses a collection of symbols, words, and phrases which instruct a computer to perform specific operations. Okay. All right. Next page here, and once again, guys, I'm using the old version of the book, so bear with me if my page numbers are not quite accurate, but you kind of get the idea of what I'm trying to do. Figure 13, 15, it might be different in the newer book, gives an example of different types of programming languages. Starts off with C++, Java, JavaScript, Visual Basic, and of course something else here called Swift. There are a lot more others, but this gives you a general idea of what programming languages are, and it also does a decent job of trying to describe what these different programming languages do. Okay. Next step, which is the fourth step, is the actual program test. And there's a key word here, is called debugging. And debugging is the process of testing and then eliminating errors, getting the bugs out. This is an important step, guys, because if this isn't done, a lot of times the program will have a lot of errors, and by the time it goes live, meaning by the time it's actually put into practice, it could develop, some major issues. So yes, I do want you guys to read through some of this because it gives some details on what could happen when these errors go wrong. Okay. All right. I'm going to move on to step 5, which is program documentation. The program has to be documented. That is essential. And this program documentation process is carried on throughout all of the programming steps. And this is important, guys, because a lot of times when programs are written, if you don't document it and there are errors, sometime in the future when they have to come back to fix a couple of things or adapt the code, it can be problematic if nothing is actually written down. Okay, sixth step again is program maintenance. So the program has to be maintained. All right. The book says that as much as 70% of the total lifetime cost for an application program is maintenance. And again, I point you to Windows 10, for instance, that needs updates sometimes almost on a daily basis. That is called program maintenance as well. Okay. Case tools, sometimes if you want to make the work a little bit easier, you might need these case tools to make the work a little bit easier. The easy example I tried to give earlier on is sometimes if you don't want to go through the whole programming steps, you might decide to purchase these pre-programmed programs that can help you get the job done without going through those programming steps. Again, do want to read through this at least once or twice just to kind of have a general idea about what PACE means and what OOP means as well, object-oriented software development. All right, lastly here, it talks about generations of programming languages. I think I mentioned this already, but there are different levels. The machine language level is closer to what the computer understands. We talked about zeros and ones being binary numbers. That's how computers kind of decode things. But as you start going higher, where humans are able to understand coding and programming languages, the language is start to change from machine language to assembly language to what's probably now called procedural language, which is where we start to understand what the programming language is saying or is attempting to do. We're now probably in what I would call the third generation programming languages. That's probably what we use more often, where you don't necessarily have to be a programmer, but you kind of have to have some programming experience to understand what a third generation programming language does. Now, fourth generation programming language is where it gets a lot more easier for non-programmers to understand what the language is actually saying. And I also talked about the fifth generation, which is more closely linked with artificial intelligence, and where humans will not necessarily be involved. So that's my quick overview of this last chapter on programming. I do definitely want you guys to review, and like I said, guys, what you probably want to do is look at the visual summary at the end, because it just makes it a lot more easier. And I do like the picture illustrations they have at the end. They kind of make things a lot more simpler. All right, if you have any questions on this, you can email me, ask any questions. But again, I wish you guys good luck, and I look forward to seeing you guys for our last class review tomorrow, Tuesday. Bye.